Hello, thank you for watching this video. So, on this video I'll be doing question 7 of November 2020 Mathematics Paper 1, and that is the beginning of calculus. So it's grade 12, obviously. So I'll start with 7.1. 7.1. Determine f prime at x from first principles if f of x is equal to 2x squared minus 1. So what they're asking you here, they're asking you to determine the derivative of this function using first principles, which is using the derivative definition, right? So they want you to find what is f prime at x, which is f prime at x, which is the derivative of this function, using first principles, which is now using the definition, the derivative definition, the formal definition. That's what they want you to do. So what is our derivative definition? Our derivative definition is telling us that f prime at x is equal to the limit as h approaches 0 of f at x plus h minus f of x all over h. So this is our definition. This is the definition that they are asking us to use to find the derivative of f, right? So as you can see, this is straightforward. So you are taking the limit of this as h gets close to 0. So this is f at x plus h, which means now for your f, so this is your value of x plus h. So you have this it's more like you substituted x plus h here, which means you must also substitute x plus h there when you see your x value, right? This is what you do here. So first part, f at x plus h, f at x plus h there. So your f x plus h is equal to 2x plus h squared minus 1, which means when you see your x, you put on your x plus h. And then the second part is f of x, which is equal to x squared minus 1, which is what we have there already. So this is what the first part says, which means now when you see your x value on your function, you put x plus h, which is what we did. Then once you have this, you substitute it on your limit definition, on your derivative definition. So now you say, okay, f prime at x is equal to limit, going back here, as h approaches 0 of f at x plus h. This is what you put there, f at x plus h, because x plus h, f at x plus h is this, which is that thing there. So you have 2 into x plus h squared minus 1 minus, which is now you're minusing x, f of x, which is this, 2x squared minus 1, all divided by h, which is this part here. So the next thing, you just simplify what you have here. So what do you have? You have limit as h approaches 0 of what? 2 in times x squared plus 2xh plus h squared. So you are expanding what you have on your bracket there. Minus 1, which is this times that, minus 2x squared plus 1, all divided by h. At this point, straightforward. You have only simplified what you had there. So let's continue with our simplification. So what do we have? We have the limit as h approaches 0 of 2x squared plus 4xh plus 2h squared minus 1 minus 2x squared plus 1. So this part here is this, which was you got by multiplying out this bracket, right? So this is all over h. Next step, take the like terms. So this and that goes away, because it's going to 2 minus 2x squared minus 2x squared. And then this and that goes away. So you are left with limit as h approaches 0 of what? Of 4x h plus 2 h squared all over h. Right? What do we do? At the top we take the common factor, which is h squared. So what do we have? We have the limit as h approaches 0 of h into 4x plus 2h all divided by h. Right? So this and this cancel out. Right? So I'm going to stop here and go start from the top. Hopefully it's clear from this from the beginning here. So what they gave you, you were given f, and so they said they want the derivative from first principle, which means using this definition here. So what you did, say, okay, they are saying limit as h approaches 0 of f at x minus h minus f of x all over h. So f at x plus h, which means you substitute x plus h there, which is this, and you put your x plus h there, which is you get this part here. This part here. F of x is that. Then you substitute this from your definition, which is this here. So after substituting from your definition, the only thing that I did is to simplify up to this point. So I'm going to delete everything up here so that I can continue. So limit as h approaches 0 of what? So what do we have here? We have this and this went out. We have, don't forget your equal sign. We have, okay, actually, because I've deleted it, so I'll say f prime at x is equal to the limit as h approaches 0 of 4x plus 2h. Right? So when you get to this point where you have removed, where your h that was the denominator have moved away, you allow. So what you do now is to allow your h to approach 0. Right? Which now you substitute your 0 there. So f prime at x is equal to 4x plus 2 times 0. Therefore, your f prime at x is equal to 4x. So here is your f prime at x using the definition. I hope this is clear. So let's go to 7.2. 7.2. Determine. So 7.2.1. So 7.2.1, they are saying determine the derivative of this with respect to x. Determine the derivative of this with respect to x. Right? So, at your level, grade 12 level, so there are rules that they expect you to derive on. So, rule number 1, you must remove or simplify all roots. So that can be the square root, that can be the cube root, that can be the fourth root, that could be the fifth root. So you must remove this root here by expressing it in an exponential form. So you must remove roots to exponential form. That's what they want from you. That's the first thing they want. Second thing is remove all brackets. If what you want to derive is have brackets inside it, you must remove all that. That's the second thing they want from you. So 2, you must remove all brackets. Number 3, you must not have any variable on your denominator. So you must not have any x on the denominator. If this is a fraction, or you have some rational function, you must not have any variable on your denominator. So they're saying no variables on your denominator. Right? And the fourth that I can come up, or that I can think of, simplify the product between two, simplify all products. So you must simplify So, in this case, we must remove all roots, which means now we must take care of that root and write it in an exponential form. Which means here, if you have the fifth root, that means, okay, so which means this one applies here. So, we will have to remove the root. That's what that means. Remove all brackets. We don't have brackets here inside this. So ignore this bracket. We don't have bracket within this thing that we want to derive here. So this does not apply. No variables on your denominator. So we don't have any denominator there. So this also does not work. The fourth one, simplify all products. We don't have any products inside here. So this also does not work. So the only one that works is the first one. So we'll have to simplify this to some sort of exponential form. So let's go and do that to simplify the fifth roots that we see there. So to simplify the fifth root, you say, okay, d dx, what is that? It is x 2 over 5 plus x cubed. So this is the simplification of that root. So when we're here, we are ready to derive. So you can start deriving this. So to derive this, we say, okay, you know how to derive. Say, equal to 2, so it's 2 over 5 times x, so it's 2 over 5x. Then you subtract 1 from 2 over 5, so 2 over 5 minus 1, that is minus 3 over 5. So it's your exponent times x, which is this, then you subtract 1 there on your exponent, you have that, plus 3 times your quotient of x, your coefficient of x, which is 1, so you have 3x, then you subtract 1 there, which is squared, right? Then you can leave it here or simplify it if you can. So to simplify it further, you can say, okay, 2 over 5, 2 over 5, okay, then you take this part to your denominator so that it can stop being negative. So it's going to be 5, this to your denominator, so this comes next to 5 here. So x raised 3 over 5 plus 3x squared. So this is equal to 2 over 5. So you know this is the 5th root, so it's the 5th root of x squared, of x cubed, plus 3x squared. This is how you derive 7.2.1. So we proceed to 7.2.2. So hopefully this is straightforward. So what we did, so they want us to find the derivative of this. But the problem with this is that we have the 5th root. So we must write this 5th root in an exponential form, which is this, right? And then you can derive this. This times the coefficient of x, which is 1, so you have 2 over 5, x, then you subtract 1, then you get minus 3 over 5, plus 3 times the coefficient of x, which is 1, so it's 3x, then you subtract 1, then you get this. So you can stop here, but if you want to simplify it further, you take this to your denominator next to your 5 there, so it becomes positive, and you know this 5 is the 5th root, so you leave it there. Then we go to 7.2.2. So 7.2.2, determine f prime at x, determine f prime at x, right? If f of x is equal to 4x squared minus 9 over 4x plus 6, where x is not equal to minus 3 over 2. So they want us to find the derivative of this. That is what they want you to find, the derivative of this. So we said on the previous question, we cannot derive if you have a root. You must be written in an exponential form. There is no root here. Secondly, we said we cannot derive if we have a variable on the denominator, which we do, right? So let's sort that out. Let's try to remove this variable x on the denominator. So to do this, we can say, okay, at the top we have 2x squared minus 3 squared, right, over 2 into x plus 3. So as you can see, at the top we have a difference of 2 squares, right? So you can factorize that into 2x plus 3 and 2x minus 3 all over 2. Sorry, it should be 2 here. Into 2x plus 3. So this and this goes away. So what are you left with? We're left with f of x is equal to 2x minus 3 all over 2, which is the same as 1 over 2 into 2x minus 3. So you can derive this. You will be able to derive this with no problems. If you can go to our checklist of the rules you should use to derive, you will see that you will not have any problems deriving that. So your f of x is equal to 1 over 2 to 2x minus 3. So f prime at x, which is the derivative at x, is equal to the derivative of this. So it's 1 over 2. Derivative of this is 2, because it's going to be 1 at the top times 2. 1 here times 2, which is 2. X 1 minus 1, which is 0. This derivative of a constant is 0, right? Therefore, your f prime at x is equal to 1 over 2 times 2, which is equal to 1. So your derivative of your f prime of your f of x is equal to this, is equal to 1. That's how you do this. Hopefully it is clear. Thank you for watching. Goodbye.